Scalar functions are handy for writing transact SQL code that you want to use repeatedly to return a single value, whether the calculations use data from a table or not. These kinds of functions are the closest thing in transact SQL to a conventional function in most modern programming languages. Here's an example of a scalar function that computes a discount from an amount and a percent that is supplied as an integer. So it has a price that's of data type money and a discount of data type int. And it's going to return a money type because it's going to return the discount value. If I have null input, I just want to return null. So I have that with clause there. And then it declares the work, money, and then assigns the value of price minus price times discount times 0.01, because discounts are stored as whole integers. And then it returns that value. All right, so I'll execute that. Now exists within the Northwind database. Then you can use that scalar function in a view, stored procedure, or another function. And so here's a simple example where you calculate the discount price, passing in the unit price, so this is the value of the column, and I want to use a 5% discount in this value and a 3% discount right here. And so one of the nice things about this is it shows that you can execute the same user-defined function multiple times within a single select statement. Highlight that and execute it. And now you can see that we have the product ID, the product name, the original unit price, and then what the price is with 5% off and the price with 3% off. So the idea here is that you're using a scalar function to perform a calculation that you use over and over again. You very easily could have done the same calculation in line right here, but this encapsulates it, and so if there's any new logic or this logic changes or whatever, you only have to change it in this one place, and the select statement continues to work. Maybe it's embedded within a stored procedure, and you don't then have to change the stored procedure when this logic changes. Both inline and multi-statement functions can be used anywhere you use a select statement, in stored procedures, views, and other table-valued functions. But they're most useful when you need to return a set of data rather than just a single value, and you can customize how the function operates by using parameters. That, in fact, is the single biggest difference between a view and table-valued function, the ability to use parameters. So the situation is that you have a view that you have to create over and over again because it's just slightly different that you can handle through a parameter. A better way to do it might be to use a table-valued function. Here's an example of another user-defined function. Now, I did things a little bit differently here. This shows you how you can test to see if a function object already exists. So I'm using the object ID function, passing in the name of the function, including the schema. And if the return value is not null, then I want to drop the function. So this is a code that you can use in order to test to see whether the function currently exists, and if it does, it automatically drops it. Then the function itself is going to return a table, and then it uses a single return statement in order to select data from order details, and it's returning the order ID and a sum of the total amount of each sale. Okay, so I'll execute this code, create the user-defined function, and then this shows how you can use it within a subquery. So suppose that you'd like to find all of the customers and orders in the USA for whom the total order is greater than the average total order in the order details table. So the code uses this order by employee country user-defined function and then joins that to this new order total function. And it's just like joining two persisted tables. This returns a table, this returns a table, and you can do a join between them, as long as you have fields that are in common that you can join on. And then the code uses that order total again, that function again, within the where clause in order to select the average total sale amount so that we can compare the value of total here to that average amount. So essentially what's happening here is that this is a fairly complex query, not over the top, but it's starting to get up there. And you can break it down into different components by defining user-defined functions and then writing a much simpler select statement in order to retrieve the data. And we can execute that, and you can see all of the orders where this condition is met. So the important thing from this example is that inline functions let you simplify an otherwise complex query, and you can plug the functions in different places in various T-SQL statements. Basically, anywhere you can access a table, you can use a table-valued function. Hopefully you've started to get the sense that UDFs are a very nice feature of T-SQL that help you modularize code and help make it more reusable. Used properly, they can help your code perform better and make it more maintainable. But if used improperly, they can be a serious detriment to performance. The biggest potential hit to performance is when you invoke a scalar function in a query to provide a column value. In that situation, the function executes once for every row in the result set. If the result set is huge, that can mean that your UDF is being executed many, many, many times. And that can have a huge negative performance impact on large result sets. And now I'm going to take a look at an example that demonstrates this problem, although it's a little bit contrived. For this example, I'm going to use the AdventureWorks 2012 sample database. And the reason is that it has some tables that are much larger than in Northwind and is going to be able to show the problem more dramatically. So here's a scalar function that calculates the total sales amount in the sales order header file and returns it as a money value. It's a fairly simple, straightforward example of using a function to return a single value based on data within a table. All right, so I'll go ahead and create that. And then we can test the function. And so we have a huge number of sales within the AdventureWorks company. Now, say that you want to use the function to return records from the order details table in order to calculate the percentage of total orders each line consists of. So here's one way to do it. So I'm going to select the top 1,000, retrieve some fields, and then do this calculation. So I'm taking the line total, which is a column from the sales order detail, and dividing it by the amount calculated by that user-defined function, which means that I'm going to divide by that value right there. And I'll multiply by 100 and say percent of total. All right, I'll go ahead and execute that. And it's executing, and it's executing, and executing, and finally succeeds. As you can see, on this relatively speedy machine, it took 7 seconds for the query to execute. That's a relatively long time in order to retrieve 1,000 rows of data. Now there are 121,317 rows in that table, so you can see why I used the top statement there, because I didn't want to wait for a really, really long time. You get very bored watching this video. Now the reason this is taking so long is that every time this select statement processes a row, it has to look at the line total for the current row that it's processing, and then it executes this function again. So in essence, it's executing this function 1,000 times for the 1,000 rows that I returned from this statement. But what's a waste here is that every time I execute this, it's going to return the same value. Well, with limitations. There could be other processes that are inserting orders that are going to change that value. So it could change a little bit over time. But for the most part, for this simple example, just think of it as a constant value. But somewhat more importantly is that for this kind of information, if I'm calculating this percent of total, I don't want that total order number to be changing, because when I start getting the first set of rows, it might be one number, then it changes a little bit, ends up being another number, and so forth, as I process all of the rows going down in the result set. Okay, so this way of using the user-defined function is problematic both because of performance and because of the potentially inconsistent results. So a better way to do it is to execute the function once. So in this case, what I'm doing is I'm declaring a money type total orders variable and calculating that number. And then I'm using that fixed amount as the divisor within the select statement. And so when I execute this, you can see that I get back 1,000 rows virtually instantaneously. The moral here is that you should avoid invoking functions multiple times, particularly when they return the same data, no matter what context you execute them in. If this user-defined function was actually making a calculation based on columns, the data within the table that's being accessed, that would be a different thing. You would have to execute them each time. But if it returns the same value, or essentially the same value, with every time you invoke it, then you don't want to include it within the select statement like this at all. And when there is a legitimate reason to invoke a UDF for each row in the table, again, such as performing that where you need data from each row in order to perform the calculation, you want to keep the code in the UDF as small and tight as possible and confirm that the performance hit is manageable, because you can easily take down a server if you have a misbehaving user-defined function. Multi-statement functions have their own potential problems. One issue is that they use tempdb to pass the table data to the calling code. It's just the internal technique that it uses. Most of the time, that isn't a problem. But in a heavily used system, that can cause performance problems. Another issue identified, and this is something I picked up within the create function topic in Books Online, is that even though you can do a join with a multi-statement function in the from clause of a select statement, you should avoid it if at all possible and do the join on the base tables instead. This is because SQL Server can't use all of its optimization techniques in all possible statements within the function, so it's probably going to create a less than ideal execution plan. This is something that I expect Microsoft will refine and improve over time, because they're constantly optimizing and improving the execution engine within SQL Server. So the moral here is that there are potential performance traps when using UDFs. But this is really no different from any other T-SQL code. It's all too easy to write poorly performing code of any kind, and UDFs are no exception whatsoever. There are almost always multiple ways to do things when writing database code in SQL Server, and the chances are good that if you evaluate performance to identify bottlenecks, you can greatly speed up query operations. So this is why SQL Server is somewhat unique database code, that you can't just write code and then leave it. You have to kind of constantly keep an eye on it to make sure that it's not causing performance bottlenecks, particularly in heavily used systems. All right, so all of this begs the question, how do you choose between using function views and stored procedures? All right, so there's some basic guidelines that I can give you. First, scalar functions really don't present an issue. These kinds of functions perform tasks that can't be handled as efficiently by either stored procedures or views, and they let you encapsulate common T-SQL programming tasks for reuse later. But they do have some potential performance issues that I talked about. If you need to use parameters, then views aren't going to work. If you need to perform action queries, stored procedures are your best choice. And that still leaves several areas of overlap. And one concern that you may have is how the performance of functions compare to views and stored procedures. Now, Microsoft has stated that their intention is that no performance penalty results from using functions rather than comparable views or stored procedures. Now, this isn't addressing the issue of improperly using functions. It's just if you take a chunk of code and put it in a function, it's Microsoft's intention that SQL Server will execute the code as efficiently no matter how you encapsulate it. So one of the things you might want to do is consider rewriting views as inline functions, especially if the addition of parameters would be helpful. In many cases, judicious use of parameters let you substitute one inline function for several views. Parameters can also protect your data and your network load by forcing users to narrow their selections. So instead of accidentally returning 100 million rows, you restrict data access through a function or a view and require the user to specify parameters that limit the amount of data that's returned. You'll be better able to sleep at night, for example, knowing that no user will be able to update all of the last names in the customer table to smatters. They'll have to choose one customer who really did change her name. That's the kind of benefit that you get. Now, views do offer the performance benefit of support for indexing. You can't create indexes on functions. You could, however, wrap an index view in an inline function that selects from the index view. This gives you the advantages of index views and also allows you to work with parameters. It's kind of really is the best of both worlds. For some tasks, such as creating or modifying database objects, your best choice is still going to be stored procedures. But if you'd like to be able to select columns from the result set or even update it, then user-defined functions are worth considering. And there are some stored procedure types that are good candidates for rewriting as user-defined table-valued functions. One is that if the stored procedure returns a single select statement and has input parameters. Another is if the stored procedure builds an intermediate result set using a temp table, which is then queried in a single select statement. Or if the stored procedure doesn't perform any update operations except to internal variables. And finally, if the stored procedure doesn't use dynamic execute statements. So those are a few of the ways that you might consider converting to functions.